Hello students, I welcome you all for Math Inquiry Learning Journey organized by the GEM Foundation, where we share simple ideas to make young children think and explore answers for their curious questions that they have in math concepts. So in this episode we are going to see an important question that you all have: why negative into a negative is a positive? And you actually understand that it is happens to be so. And when you have this why question on why it happens so and how I can understand better, only then your interest and your understanding gets deeper and you get a good clarity on the things that happens with math. So in this video, let's have some small activity using counters and understand the multiplication of integers. I would encourage you all to check few videos that's been already published in this about working with the positive and negative integers from addition and the subtraction perspective, which will give you a good base. Now let's move ahead and understand multiplication using counters. So you may be actually knowing multiplication earlier also, right, with respect to addition. So what is it? Yes, it is basically multiplication is repeated addition. That's how you have been learned, right? So if ask you to write different types, you can write it different integers that you want to multiply. What are the different types of multiplication you can think? Just note it down. We'll see in a short while what are the different types that can come. Yes, so I think you have already been writing because integers include positive and negative. So you may be writing minus 4 into 5, what is it? And minus 3 into minus 2, what is it? Or minus, or for example, plus 7 into minus 2, right? Or the normal example of adding two numbers, 4 times 3. Right, so these are some four different possible ways that you can multiply integers. Of course, you can add so many numbers again, but then this is the basic combination that you can think of. So now let's try doing it with the counters. How do you do a positive multiplication, like positive integers? If you want to multiply 3 times 2, so basically you have 3 and you are adding it 2 times, right? So repeated addition of 3 2 times. So that represents 3 plus 3, which is nothing but 3 you are multiplying 2 times, and that is 6. Yeah, so this is a bit simple to understand. Let's try another different way here. So you are adding minus 2 3 times. So how do I represent? So minus 2 you can represent with the red counter and positives with the yellow counter. So you have minus 2 and you are adding minus 2 repeatedly 3 times. So minus 2, minus 2, minus 2. If you add minus 2 repeatedly 3 times, how many in total you get? So you get 6 red, and minus 2 plus minus 2 plus minus 2, you're adding 3 times, and that is minus 2 times 3. You get minus 6 counters, isn't it? Yeah, this is clear. So now let's go ahead and try doing 3 times minus 2. What does it mean? So here I am adding, right? So when I say 3 times, I am repeatedly adding. What does this minus 2 corresponds to? Now let's try to understand what does 3 times minus 2 mean. Basically, how do I represent? So 3 represents 3 yellow counters, but how do I represent minus 2? Because here, when I represent 3, it means repeatedly adding 3 times. What are you adding? You are adding a group of minus 2 3 times. So how do I represent this minus 2? What does it mean basically? So from our earlier discussion on subtraction of integers, minus 2 means taking away 2 times, right? Taking away 2. So minus 2 represents taking away 2 times in this case. So you are taking 3 yellow counters 2 times. That's what you are trying to model. So consider this, like for example, this is your table which has nothing. And you want to take away groups of 3 2 times. So you can consider this as uh, taking away. Taking away is represented by this minus, taking away groups of 3, which is 3 positive counters. How many times? 2 times. And this is represented by the 2. So if you want to take away groups of 3 2 times, you don't have anything. So how do you take away 3? So if you want to take away 3 one time, you add 3 yellow and 3 red, because this is 0. 0 can be nothing, or 0 can be plus 3 and minus 3. Now, can you take away a group of 3? Yes, I can take away a group of 3. So this circled one has been taken away. Okay, fine. But I have to take away 2 times. So I should do this exact thing another time, right? So I don't have 3 yellow to be taken away. So I'm adding 3 yellow and I'm adding 3 red, and I take away 3 yellow. So 2 times. So this is the first time and this is the second time I have taken away. After taking away groups of 3 2 times, how many I am left with in my table? I have 1, 2, 3, 4, 5, 6 red counters, which means minus 6. So therefore 3 times minus 2 is minus 6. So basically you are taking away groups of 3, taking away 2 times. So that's how you can understand how you have gotten minus 6. So try doing maybe, for example, 4 times minus 2, taking groups of 4 2 times, taking away, and you get minus 8 in total. So try communicating this to your friend or to anyone so that you get a good clarity on what you're working with these counters. If you have any notes, please do write it in the comment section. Now, with this understanding, we are going to do this one a bit easier. Minus 3 times minus 2. So what does it mean basically? If we kind of try understanding this and extend it to negative times minus 3 times minus 2, what does it mean? So basically you can say that I have a group of 3 negative counters and I need to take away 3 negative counters 2 times, right? So basically I don't have anything, but I want to take away. So this minus 3 represents group of 3 red counters, which is negative. Group of 3 reds, take away, which is represented by this negative, because if it is minus 3 times 2, minus 3 times 2, it means you are adding red counters, which is the negative counters, red counters, addition, repeated addition, right? 2 times. This is what it means when you do minus 3 times plus 2. But here it is minus 3 times minus 2, and in this case it is not repeated addition, it is repeated takeaway, right? So groups of 3 reds taken away 2 times. So what do? Okay, I don't have anything now and I have to take away 3 red. So if I want to take away 3 red, so 0 I can represent it as minus 3 and plus 3. So now it is also 0, right? And can I take away a minus 3? Yes, I can take away a minus 3 one time. A group of minus 3 one time. But I have to take away a group of minus 3 two times. So what should I do? I should do the same thing again. So I don't have anything. I add 3 red, I add 3 yellow, and now I can take away 3 red, which is 2. So which basically after taking away group of 3 2 times, I am left with 6 positive counters, right? So this is how you can represent minus into minus is actually a plus. Yeah, so understanding this matters a lot on what does minus 3 mean. It's groups of 3 red or a minus 3 counter. And what does this minus mean? It means you take away 2 times. Exactly. So this is how negative into negative is a positive. And I encourage you all to share this mathematical communication to your friend or to someone by explaining this modeling to have a good understanding. I hope you all enjoyed this modeling activity with which you gain clarity on how do you do arithmetic operations using positive and negative integers, and also especially the why and how behind these multiplication of two negative integers. And I also would like to tell an important point here, that the usage of negative numbers and the rules for performing these arithmetic operations that we saw using different modeling activities using negative and positive numbers was first stated by the 7th century Indian mathematician called Brahmagupta in his book Brahmasputa Siddhanta. He wrote a dot symbol above the number to represent it as a negative number, and that kind of helped pave way for everyone to work with negative numbers. So, all of you have interesting questions and follow this math inquiry learning journey to figure out how to find the answers for your interesting questions through interesting ideas and activities. Thank you.